Hi students, problem number 12. Calculate the de Broglie wavelength of a proton whose kinetic energy is equal to 81.9 into 10 to the power of minus 15 joule. Given that the mass of the proton is equal to 1836 times that of the electron. Very direct question. Simple mathematical calculation only is required here. So it is given that the kinetic energy is 81.9. I am using the symbol Ke max is equal to Ek. So that is equal to 81.9 into 10 power minus 15 joule. And mass of the proton is 1836 times that of the electron. And the electron's mass is 9.1 into 10 power minus 31 kg that we are supposed to remember. Okay. Now we have to use the equation lambda de Broglie wavelength of the proton is equal to, okay, Planck's constant h divided by mass into velocity, that is equal to what? H by p. P is for momentum, and this is the required equation. Now we don't know direct value of momentum, but they have given the kinetic energy. We can relate momentum and kinetic energy, is it not that? So kinetic energy is equal to P square by 2m. This implies P square is equal to 2 into m into E kinetic, or momentum P is equal to square root of 2 into m into kinetic energy, and this is equation 2. So I want to substitute for P equal to square root of 2me in the first equation. Therefore, de Broglie wavelength lambda is now equal to h divided by square root of 2 into mass of the proton into kinetic energy. So lambda is now equal to 6.626 into 10 to the power of minus 34 joule second divided by square root of 2 into. Now since they have expressed the mass of the proton in terms of the electron, we are substituting. Actually, if they have not given this information, directly the mass of the proton we can substitute, is it not? Okay. So that is 1.67 into 10 to the power of minus 27 kg. Directly we should have substituted. But since they have given the mass of the proton in terms of the electron, so in place of m I have to substitute what? 1836 into 9.1 into 10 to the power of minus 31 into kinetic energy is also given. So 81.9. So into 81.9 into 10 to the power of minus 15. So such a large number. Now this product and all you can easily do. You can work out in the rough sheet, is it not? But taking square root, you have to practice how to take the square root of a number using half into logarithm of the number. Okay. Anyhow, now we will use a calculator and learn the method of doing this problem. Okay, you practice using a logarithm also. So now this is equal to 6.626 into 10 power minus 34 divided by square root of, I will multiply all these numbers. Now 10 powers I will write 31, 15 is 46. Okay, first 2 multiplied by 1836, 1836 multiplied by 9.1, again multiplied by 81.9, so that this is equal to, a very large number is coming, 2736 704.88 into 10 to the power of minus 31 minus 15 will become minus 46. If you take square root for minus 46, it will come as minus 23. Is it not? So this is now equal to 6.626 into 10 to the power of minus 34 divided by the square root of this number. Okay. So 2736 704.88. So for this the square root value is 1654. So 1654.29 into 10 to the power of square root of minus 46. No, this will be 10 power minus 23. So once again now we have to take this fraction. So 6.626 6.626 divided by 1654.29. So this is 6.99 is coming. 6.99. Okay. So divided by 29 into 10 to the power of minus 5 is coming. Okay, 10 to the power of minus 5 into this 10 power minus 34. This is plus 23. So plus 23. So that this is 39. That is into 10 to the power of minus 34 into 10 to the power of plus 23. So the powers we will have to adjust now. Okay. So I will recheck this value 6.26 divided by 1654.29. So that this value is coming, this fraction is coming as 0.00400. This is the corrected value. Okay, so I have checked this fraction to be 0.00400 into 10 power minus 34 and 10 power minus 23. If you adjust means this is a 10 power minus 11. Okay, minus 11 will come. Okay, now you can adjust the decimal places accordingly, 4.00 like that. So that this will be what I am shifting the decimal 3 digits. So this is 4.00 into 10 to the power of, when I shift this, this will become 10 power minus 14. Okay, 10 power minus 14 meter. So we have found the answer as what? Lambda is equal to 4 into 10 to the power of minus 14 meter. So this is the de Broglie wavelength of the given proton. Okay. So what simple concept only. This is the de Broglie wavelength in general expression lambda equal to h by mv or h by p. Just momentum is expressed in terms of kinetic energy because kinetic energy is given here. So concept is very simple, but calculation is very tedious. Okay, so practice the calculation in a shortcut method by using logarithmic calculation. I hope you must have understood well. Fine.